In consumer theory, uh, to know the consumer surplus is an important thing to know, just to know that how well off is the consumer in a certain transaction. Here the integrals can help us to assess this important variable. In this process we know that consumer willingness to pay is also an important variable to know. So all of these variables we can find out by using the integrals and a few other formulas. So let's get started with this economic application in a numeric form. This is the inverse demand function that is given, where P is a function of Q. Precisely speaking, an inverse demand function is given, and we are to find out the consumer surplus. And we are also informed that the consumer willingness to pay is 3 units of the commodity, and during this using this information we can plot this graph like this. The Q variable is on x-axis and price variable is on y-axis. This is the inverse demand function, and using this inverse demand function we have used the information about the consumer's willingness to pay for 3 units. When we take it to the demand curve, it reaches here and it guides us about the certain level of the willingness to pay, that is at equilibrium the value would be 64. And this is done by simply putting this value of 3 in the demand function, that is the value of Q. Wherever there was Q, we substituted 3 and we found that we have 64 as the equilibrium price. Now we have a few things here, that is the equilibrium output, equilibrium price, and this shaded area which is shaded in blue. This definitely highlights the consumer's willingness to pay within the range that is 0 and 3 of the units of output, and you can see it is shaded in the blue color. Now we are going to visualize the graph like this. As you can see, we have done the same thing as we did before, that we developed the equilibrium output as well, which was 64. Algebraically it was found as well. Now we have 2 areas in it. In this overall trapezoid we have one part which is this triangle and the other part is this rectangle. You will see that we will highlight this in upcoming pages. This is the specification of the triangle. This is the specification of this rectangle, and we have highlighted this in the next diagram. As you can see, now the various vertices are now highlighted, what they are, if they are represented by P or E or any other alphabet. Now this is easy to understand with this labeled diagram, that what is the consumer surplus, what is the expenditure, and on the whole this blue area is basically the area under the curve between 0 and 3. This is what it is in terms of an integral. So we can use this virtue of integration on this given function to find out the area under the curve, which is one of the things that we want to know, because this area is actually the willingness to pay. So this is the explanation of this part. The area under the curve is actually the definite integral, which can be symbolically written like this, and this would be the situation after the substitution of the demand function, which is the inverse demand function. So if we do this, we will get the area of the trapezoid, that is OQ asterisk EP. That is the area which is shaded in blue, and one pair of the sides have parallel, that is these two left and right sides. The upper side is definitely not parallel to the base, which is horizontal, this one. So this is the identification of a trapezoid, and in its economic sense is that it is showing the consumer's willingness to pay for 3 units. As you can see, this is the consumer willingness to pay, and then the expenditure is calculated of by using the area, calculating the area of this rectangle. This is the length into width, and it can also be written like this. You can pause the video and see that how these notations are used of OQ asterisk and P asterisk E, and then OP asterisk and EQ asterisk. So this is actually the actual expenditure that we have done, the output that we have at equilibrium, and the price that is there at equilibrium. So this is the actual expenditure done on that certain amount of goods that are sold at a certain level of price. Now this triangle is the remaining part. If I subtract the rectangle from the overall trapezoid, the left area would be the consumer surplus. So we can simply take the difference of the two. This is a diagram that guides us about the consumer surplus, and this is willingness to pay. As you can see, willingness to pay. This is the actual expenditure, and this is definitely the consumer surplus, something that we are looking for. So the area is defined like this, that is the area under the curve. This is the actual expenditure, and this is the triangle, because this is the sum of these two. This is equal to the integral or the overall area that we have. Now we can rearrange it, because we are in search of this value, that is the triangle, which is the consumer surplus. So we are rearranging it, and once we rearranged it, we got this. This is the length into width formula for the rectangle, and this is the area under the curve, for which the inverse demand function is used. Now the remaining thing is usual, that we are going to apply the definite formula, a definite integration formula here, and this is the area of the rectangle. Here it is being solved, that is the area under the curve using the definite integrals. You can pause the video and you can see that how this is done. 192 is the answer of the rectangle. Now the remaining steps are very easy. By using these simple arithmetic steps, you can find the area of the triangle, which is the consumer surplus, and we can say that this is the consumer surplus, that is 72 units. Now this is labeled in this diagram that we have been using. This is the diagram, and we can see now it is equal to 72 units depending upon the units of price that we have. So this is how we can develop the formula of the consumer surplus. This is how we can understand the numerical application of it. This is how we can understand the diagrammatical depiction of the consumer surplus, actual expenditure, and the willingness to pay. And this was done by using the formula of definite integral, and simply by using the formula for area of a rectangle. So definite integrals can help us to find out something significant in the consumer theory. Thank you.